Okay, so we're going to learn our third way to solve systems of equations today, which is by elimination. So this is 3.3. We're going to solve them algebraically again, and then again with our real life scenarios, which is our word problems. So we did graphing where they intersect, and where they intersect was our solution. Substitution was where one or both of the equations given to you in the system was equal to a variable, so we just substituted that part into the other equation. And then elimination is a little bit different because not all of our equations are going to be written in slope-intercept form, and we don't want to have to rewrite an equation in order to start solving. So we have a third option called elimination, and elimination is exactly what it says. So elimination is literally meaning that we are going to get rid of a variable. Okay, and the only way to get rid of a variable is to make it cancel out. And the only way to do that is by making the variables the exact opposite amount. So making the variables the exact opposite. So if we had 3x, we would want the other equation to have negative 3x, so that those would cancel out and we'd be left with just a y. That's called elimination, eliminating a variable, getting rid of it. So you can tell why in this one you wouldn't be able to use substitution or graphing as easily without causing you more work, because this one is written in standard form and so is this one. So the only way to solve that would be to rewrite them both and then go from there. So we're going to use elimination in order to help us have a different type of solving for each situation that we're given. Okay? So for elimination, you can do several different choices, and you can pick every time which one that you'd rather eliminate, the X or the Y. I always look for whichever one will cause me the least work. But you're going to input the same answer no matter which one you pick, as long as you multiply correctly. So if you look at letter A, I'm going to probably choose to get rid of X, because I know that to make this X the opposite of the other one, this guy needs to become -2. And in order to make it -2, I would have to multiply everything in that equation by -2. Because what we do to one side, we have to do the other to keep it fair. So I'm making them opposite so that the x's will cancel or eliminate, and I can focus on just the y. So I'm going to distribute this -2 all the way through to these three things. Gives me -2x minus 6y equals -14. Now, once you have that, you're going to make a giant addition problem out of all of these terms. Okay? 2 minus 2 cancels, which is what we wanted. It's eliminated. 2 plus -6 gives me -4y. And 6 plus -14 gives me -8. Now I have a one-step problem. Divide by -4 on both sides, and y equals +2. There's the first part of our ordered pair answer that we're looking for. Remember, it's always going to be that ordered pair, x, y, because we're thinking about if we were graphing these on a graph, where would they intersect? Okay, so there's y. Now I'm going to take that y value and plug it in to either equation. It doesn't matter. I'm just usually always going to pick the top one, and everything else stays the same. So x plus 3, y comes out, 2 goes in its spot, equals 7. Okay? So then I have x plus 6 equals 7. Subtract 6 from both sides, and x equals 1. So there we have our x and our y, and that is your ordered pair solution to your system. Okay, let's go to the next one. So this one's a little bit different because we have both of our choices have numbers in front of x's and y's, so you can just pick whichever one you'd like to do. 90% of the time, I always pick x, depending on what they have for the y's, if it's just a little bit easier. So if we want our x's to be the same, we would have 7 and 2. Well, 7 and 2 only have 14 in common. That's the smallest number they have in common. So I would want my top row to become 14 and my bottom row to become negative 14. Well, in order to do that, we would have to multiply whatever we need them to become by whatever number gets us there. So in order for this to become 14, I would have to multiply this whole row by 2. And the opposite would be negative 14, which means this whole bottom row would have to be multiplied by negative 7. Okay, again, I want these to become their opposites. Okay, so I'm picking numbers to multiply by so they can become those numbers. So if I distribute 2 to everything inside of the top row, I'm going to have 14x plus 6y equals negative 24. Bottom row, I'm going to distribute negative 7 to all three. So I'm going to have negative 14x minus 35y equals negative 266. Okay. My x's are gone. Remember, big addition problem. Those are eliminated. 6 plus negative 35 would be negative 29y. And then negative 224 plus negative 266 would give me negative 290. Now I divide by negative 29, and y equals positive 10. Okay. Again, take that and plug it into the other equation. Either one, I'm just going to pick the top one. I'm going to put it right in here for y. So I have 7x plus 3 times 10 equals negative 12. So 7x plus 30 equals negative 12. Subtract 30 from both sides. 7x equals negative 42. Divide by 7, and x equals negative 6. So my ordered pair answer for my system would be 10. Oh, sorry, wrote that backwards. Negative 6, 10, xy. Okay, hopefully we're catching on a little bit. So as you look at letter C, be thinking about which variable you'd like to eliminate. Again, you don't have to always pick x. In this case, I would probably actually just pick y because there's a little bit easier numbers. But if you notice, it's the same thing probably for x here as well. So I am going to multiply. I want this is a positive 4, and I want my top number to become negative 4. Well, in order to get it 2 to become negative 4, I have to multiply it by negative 2. So whatever I choose there, I have to do to the entire row, the entire equation. So I have negative 12x minus 4y equals negative 20. This becomes one big addition problem. 12 minus 12 is gone. That's our goal. Oh, and now we have 4 minus 4. So this is gone as well. I've eliminated both variables. So if we don't have any variables, you should already be thinking about what special answer we could have. I have 0 on the left. 50 minus 20 on the right is 30. If these are not the same, then we have no solution. Okay, let's go to the next one. Be thinking about what you want to eliminate. I'm seeing that I can make my x's eliminate. If this is a positive 18 and I want this guy to be a negative 18, I have to do this entire bottom by negative 6. And then I'm going to distribute to all three. So negative 18x minus 24y equals negative 60. I'm going to write my top one right below it so I can compare. 18x plus 24y equals 60. And one big addition problem. Negative 18 plus 18 means those are gone. Negative 24 plus 24 means those are gone. Nothing left on the left side means it's a 0. Equals negative 60 plus 60 means those are gone. So nothing on the right means that's a 0. These are the same, no variables, so our answer is infinite solutions. Okay, so here are your try-its. Pause the video, see if you can get through these on your own, okay? All right, so the first one, I'm looking at x's, not great, but y's are already opposites. So I'm going to choose y's because they will already cancel. I don't even have to multiply by anything. This would be -1, this would be +1, so they're already ready to go. So I'm going to go ahead and make this one giant addition problem. -3 plus 7 is 4x. The y's in the middle are eliminated. Equals 8 minus 12, which is -4. Divide by 4 on both sides, and x equals -1. Now I'm going to take that and plug it back in up top for the x. So -3 times x comes out, -1 goes in, minus y equals 8. This gives me +3 minus y equals 8. Subtract 3 from both sides, and I get -y equals 5. Divide by -1, and y equals -5. So my final answer would be -1, -5. Okay, in the middle, I'm looking at letter B. X's would have to be 12. Y's would have to be 10. So you're going to have to multiply both of them no matter what. I see that x's are already positive, negative. So I'm going to go ahead and use my x's. So I would want this one to be positive 12. So it means you'd have to multiply it by 3. And the bottom one would need to be negative 12x. So I would multiply that one by 4 because it's already a -3. So let's distribute the top. This would give me 12x plus 15y equals 105. Bottom would be -12x plus 8y equals -36. Big addition problem. My 12s are eliminated. 15 plus 8 gives me 23y equals 105 minus 36 is 69. Divide by 23, and y equals 3. Now let's plug it back in. So y is going to go right here for y in the top one. 4x plus 5 times 3 equals 35. So 4x plus 15 equals 35. Subtract 15, 4x equals 20. Divide by 4, and x equals 5. So my final answer would be 5, 3. Again, thinking about these, if you rewrote them and graphed them on the graph, they would intersect at 0.53. Okay, that's what we're thinking about every time. Okay, let's go to the next one. Looking at my x's, I would have to multiply the top. Same thing on my y's. So I'm just going to multiply the top row. I want x to become -12, so I would have to multiply by -3. So let's distribute all three of those. -12x, -9y equals -36. And you've probably already seen what's happening here. They all became opposites, so they are all going to eliminate. 12 minus 12, 9 minus 9, that gives me 0 on this side and 0 on that side. They are the same, so I have infinite solutions. Okay. Last one on your own. I'm going to do y's this time, I think, because this is 8 and 4, so I know this guy has to be multiplied by 2, but they're both negatives. So to make this a positive, oops, wrong one. Sorry about that. Bottom one. Try that again. This one has to be multiplied by 2. They're both negative, so to make this one a positive, it also has to be multiplied by negative 2. So let's multiply here. Gives me negative 6x plus 8y equals positive 2. I'm going to rewrite this one down here below it. So 6x minus 8y equals 8. One big addition problem. These cancel. Oh, and my y's cancel. So nothing over here. And 2 plus 8 is 10. Different answers, no variables, no solution. Which again means that these would be parallel lines because they would never intersect. All right, well, hopefully you did okay with that one. Let's do our word problems and we're all done. A florist is making regular bouquets and mini bouquets. The florist has 118 roses and 226 peonies to use in the bouquets. How many of each type of bouquet can the florist make? If you see over on the right, it says each regular bouquet has 5 roses and 11 peonies, and each mini bouquet has 3 roses and 5 peonies. Okay, if you're noticing, the two separate things we're talking about here are roses and peonies. Okay, so we need to make an equation that has one all about roses and one all about peonies to get started. All right, then we'll solve for how many bouquets we have. So I'm going to make x equal my mini bouquets and y equal my regular bouquets. So for roses, I have in my regular, or my mini, 3 roses in each mini, plus 5 roses in each regular, and my total number of roses is 118. Then for peonies, I have in my mini 5, so 5x, plus my regular is 11. Oh, I put x again. I'm sorry. You guys, getting late, making mistakes here. This would be a y up here. So this is y equals 226 peonies altogether. Now we have our two equations, and we need to figure out what to multiply by so we can eliminate something. I'm going to choose to make my x's go away, eliminate, and 5 and 3 both go into 15. So I would need to multiply this one by 5 and my bottom one by negative 3. If you chose the y's, that's fine. If you chose to do the top negative and the bottom positive, that's fine. There are lots and lots of different choices here. Okay, so let's get to multiplying. We have 15x, I'm starting on the top, 5 through all of these, plus 25y equals 590. My bottom one all the way through gives me negative 15x minus 33y equals 226. Oh, no, 678. Goodness, I'm making a lot of mistakes tonight. Okay, one big addition problem. These are gone. I have negative 8y equals negative 88. So y equals 11. Okay. So that would be regular. 11 regular bouquets. Then I'm going to take that number and plug it back in up top for y. So 3x plus 5 times 11 equals 118. Gives me 3x plus 55 equals 118. I would have subtract 55. Gives me 3x equals 63. So x equals 21. So this would be 21 mini bouquets. All right. Okay, so same thing for your try it, same situation, but they've changed the number of roses and peonies that you had to start with. So you actually already have the equations correct. You're just practicing the solving this time. So we have our 3x plus 5y for our roses. And roses now only have 85, so this equals 85. Our peonies were 5x plus 11y, and we have 163 of those this time. Now we're going to solve. So I want to get rid of, we did x's last time, let's do y's this time. So my 11 and 5 would mean 55. So I would have to do the top by 11 and the bottom by negative 5, because 1 has to be a negative to be able to eliminate. So let's distribute our top with 11. I have 33x plus 55y equals, 935. On the bottom, I've got negative 25x minus 55y equals negative 815. Okay. 33 minus 25 gives me 8x. These are gone. Equals 935 minus 815, which is 120. And I take both sides divided by 8. We get that x equals 15. So 15 regular bouquets. No, I'm sorry, mini. X was our mini. Okay, and let's plug it back in. So I'm going to take my x and plug it right back into here. So I have 3 times my 15 plus 5y equals 85. So this would be 45 plus 5y equals 85. Subtract 45 from both sides, and I would have 5y equals 40. Divide by 5, and y equals 8. So 8 regular bouquets. Okay. All right, so your homework is to try these 3 down here for elimination, and you choose what you want to multiply by, and we will talk about them tomorrow in class.